Good afternoon to you all. We will be discussing the response of the RL circuit for the impulse input. This circuit, RL circuit, has been driven through I impulse. So applying the voltage law, what we obtain is V is IR plus L di by dt, as we are doing in the previous analysis. So V is delta t minus A. It's the representation of the impulse. So we obtain this equation. Now taking the inverse Laplace of this equation, delta t minus A, as we have already discussed in class, that the inverse Laplace of this delta t minus A, it was obtained to be e to the minus as. It becomes Is in S domain plus L as Is minus I0. I0 is the initial current. We have already discussed in previous lectures that I0 is 0 in such cases, since there is no initial current. So this is 0, and putting this value as I0 equal to 0, we obtain this equation, and on analyzing this equation further, what we obtain is 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 e to the minus as upon R plus Ls, rearranging the terms. So we obtain the current in the S plane. Now taking the inverse Laplace, we will be obtaining the current in the time domain. So this is the inverse Laplace of this equation. So this is the current in time domain. So pictorially it can be represented as in this way. This is the impulse, and this is the current. It can be represented that it is an exponentially falling current, and given by this vector e to the minus t minus AR by L. Similarly, moving further, the response of the same RL circuit for the ramp input. Again, we apply the voltage law. So what we obtain is V is ITR plus L di by dt. Again representing the ramp by this equation, as we have already discussed in the class. Bt minus A ut minus A. A represents the impulse, or the A represents the ramp appearing at t equal to A, and as discussed earlier, that B is the slope of that ramp. So taking the Laplace of this equation, Bt minus A ut minus A, its Laplace, we have already discussed in the class that the Laplace of this function is obtained to be b upon s square e to the minus as. ISR plus L di by dt in after Laplace comes out to be L Is minus I0. I0 is again 0. Therefore, what we obtain is this equation, and on rearranging these values, this is the value of the current in S domain. Now I have left the inverse Laplace of this equation in order to obtain the equation in the time domain. So it has been left for the students only to obtain its inverse Laplace and find the current IT. Similarly, the response of RC circuit for the ramp input. Here we have considered the RC circuit. We find that the analysis of these circuits is almost same. Again, going for the voltage law, Kirchhoff's voltage law in this equation. V is ITR plus 1 upon C integral I dt plus Q0 minus it is the initial charge, where the initial charge is taken to be 0. So ramp is represented by this equation, V equal to ITR plus 1 upon C integral I dt. Q0 is 0. Therefore, again taking its Laplace, as we have just discussed in the previous one, this is the Laplace of this Bt minus A ut minus A, where the ramp is appearing at t equal to A, and B is the slope of that ramp. So again, what we obtain is this equation. From this, Is has been obtained. So the analysis is almost same. Again, the students are requested to take the inverse Laplace of this equation and obtain the current in time domain also. This is the representation of the equation in S domain. Thank you.